Hey guys, so what we're going to do is, before you start this quiz, I'm just going to have you guys watch this. It is up to you if you want to take notes on this or not. I'm going to be going through this pretty quickly, so you will have to keep up, but it's very important that you pay attention. All right, because I tried to set this up as close to what the actual quiz is going to look like for you guys. So I definitely would make sure that you guys pay attention. Okay, so here we go. First question. A contractor is given a scale drawing of a rectangular patio. The scale from the patio to the drawing is 6 feet to 2 inches. What is the area of the actual patio? So here's some important pieces of information. First of all, that gives us our scale. We know the dimensions on the scale are right over there. And then finally, what we have to find out is the area. All right, so now that we know what the information is, now we can start to solve this. Okay, you might need to get another piece of paper out when you take the test because it might help you out. So first of all, I'm going to write down our scale. So it's 6 feet to 2 inches. And I'm going to reduce that down. So I'm going to pretend like it's a fraction. The number that goes into 6 and 2 is 2. So 6 divided by 2 is 3 feet. And 2 divided by 2 is 1. So that's 1 inch. So this right here represents our scale. Now, all I'm going to do is I'm going to apply that scale into the dimensions that are given to me. So let's do our length first. So our length would be 3 feet is to 1 inch. And then they give us on the scale drawing, it's 4 25/100ths of an inch. We have to find the actual length of that. So we know, what do you do to, these are equivalent fractions, basically, that's what they are. So 1 times 4.25 gives us 4.25 inches. So what we're going to do is we're going to multiply this top number by 4.25 as well. And when we do that, we end up getting, sorry, just a second, move my papers around here. We end up getting 12 75/100ths of a foot. So the length, the actual length is 12 75/100ths of a foot. Now we're going to do the width. So the width, we're going to start off with our same scale. Okay, and our width is 2.5 inches. So you say, what do I do to 1 to get 2.5? Oh, I multiply it by 2.5. So I'm going to take 3 and multiply it by the same thing, 2.5, and I get 7.5 feet. So my width is 7.5 feet. Now the problem, oh, sorry, that might help if you guys can see my work. Now the problem is asking us to find the area, okay? Area of any rectangle is length times width. So our length is 12 75/100ths of a foot times, that's my times dot, 7.5 for my width. And if I multiply those together, I end up getting 95 625 feet squared. Okay. All right. And that would be C on our paper. Okay. So remember what I did. I found the scale. Then I used the scale to find my length, used the scale to find my width, and then I used the formula to find my area. All right, so that's number 1. Number 2, the scale for a map to the actual distance is 4 centimeters to 60 miles. The driving distance on a map between Los Angeles and Las Vegas is 5.4 centimeters. What is the actual distance in miles between Los Angeles and Las Vegas? Record your answer on the grid, then fill in the bubbles. All right, so first step, I'm going to write out our scale. So here's our scale right there. Next, they tell us the distance on the map. So here's my scale. Notice I like to put my larger number on top. Okay, I just like to do that. Now I want to reduce this down so that my denominator is a 1. So what you could do is you can either divide them or say what's a number that goes into 60 and 4, and the number that goes into 60 and 4 is 15. So 60 divided by 15 is, oh, I'm sorry, go on back. Yes, 60 not divided by 15. 60 divided by 4 is 15 miles. 4 divided by 4 is 1 centimeter. So what this reduces down to is for every 15 miles, it's 1 centimeter on the map. So this is our scale. So now that we know our scale, we're going to substitute into a new ratio what the distance is between those two cities. So it looks like 1 times 5.4 is 5.4. So we're going to go 15 times the same number because they have to be equivalent, and it comes out to be 81 miles. Okay, so how you fill this in is you do this. It's 81. So you put an 8-1 right there, and then you go down and you fill in an 8 and you fill in a 1. Okay, that's number 2. Number 3. Number 3 says this: a map is made of a park. The scale from the park to the map is 24 miles to 6 centimeters. The length of the Great Oaks Trail is 3 miles on this map. Okay, remember that. The scale from the map from the same park to a different map is 18 miles to 3 centimeters. The length of Salamander Trail is 5 centimeters on that map. Which is the longer trail, Great Oaks or Salamander? So step number 1, we got to identify some things. So this is the scale on the first map, and this is the distance of Great Oaks Trail. On the second map is 18 to 3, and the distance on that for the Salamander Trail is 5. So first step, let's take care and find out how long Great Oaks is. So here's Great Oaks. So we know that our scale is 24 miles for every 6 centimeters. So I'm going to reduce that down. So 24 divided by 6 is 4 miles for every 1 centimeter. That is our scale. Now that we have our scale, now I'm going to plug this in to find out how long the Great Oaks Trail is. So I'm going to go 4 miles for every 1 centimeter. I'm going to set up another ratio of what I know 3 centimeters is the distance of the Great Oaks. So 1 times 3 is 3. So 4 times 3 is 12. So therefore, the Great Oaks Trail is 12 miles long. Now we're going to do the same thing for the Salamander Trail. Okay, so the scale is 18 miles for every 3 centimeters. And I'm going to reduce that down. So 18 divided by 3 comes out to be 6 miles for 1 centimeter. Now that's my scale. Now I'm going to use my scale to find the actual length. The length on the map is 5 centimeters. So what do I do to 1 to get 5? I multiply it by 5. So 6 times 5 is 30 miles. Okay, so therefore, the Salamander, let's spell this right, okay, the Salamander Trail is longer, and let's add some guts, let's add some information. And it looks like 30 minus 12 comes out to be by 18 miles. So the Salamander Trail is longer because it's 18 miles longer, because this is 12 and this is 30. Okay, all right, so don't forget this solution part. That's very important that you write that in. All right, next problem. Okay, and these were the hard ones that we just kind of talked about, so you need to pay attention to this. All right, so the scale drawing represents the aerial view of a building. The actual building has a perimeter of 96 meters. Draw another scale drawing of the building using a scale of 4:1 units from the building to the drawing. Explain your reasoning. Okay, so here we go. First of all, they're telling us that the perimeter, this is important, the perimeter is 96 miles, all right? We are going to construct another scale drawing of 4:1. So the first step is we need to find out what the scale is from this drawing to this. So this is talking about the perimeter. As you know, to find perimeter, you add up the distance around the shape. So if you look at this, if we count these up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the perimeter of our scale drawing is 12. So now what we're going to do is we're going to write that out. So 96 meters for every 12 units on here. And we're going to reduce that down. So 96 divided by 12, 96 divided by 12, sorry, let me get organized here, comes out to be 8. So our scale is 8 meters for every 1 unit on here. Okay, so that's our first step. The first step is to find the scale. The second step that we need to do is we need to find one of the side lengths measurements, just one right now. So let's start with this side right here. That side right now is 2 units. So we're going to use this right here, 4 meters for 1 unit, and that side length is 2 units long. So 1 times 2, we have to do the same thing to the top, and that's 16 meters. So in whatever this building is, this side right here would be 16 meters long. Okay. Okay, now that we know that, we can do step 3 to find our new scale drawing. Our new scale for the new scale drawing is 4 meters for every 1 unit. We know that this side length is 16 meters. We don't know how many units long that would be. So if you look at this, here's what we're going to do. 4 times 4 is 16. So 1 times 4 is 4 units. So what that means is that in our new scale drawing, this side right here is going to be not 2, but 4. So here we go. We're going to draw that. 1, 2, 3, 4. So this side is the same as this side. Now, if you look at that, it went from 2 to 4, right? So the original was at 2, and now it's 4. If you think about that, that basically doubles. So what that means is it's going to double this side. So instead of 1, it's 2, 1, 2. This side's double, so that's going to be 1, 2. This side's double, 1, 2, 1, 2, 1, 2. This is 3, so now it's going to be 6. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4 down here because that side's 2. So here's what we know. Okay, explain your reasoning. So basically, we found out that the original length was 16 meters. Okay, or the actual length, not original. Let's use actual length. So the actual length was 16 meters. Okay, using our new scale of 4 meters to 1 unit, we found that the new scale drawing would have a length of 4 units, which is double the original, scale drawing. Okay, so basically I took what I learned up here and I put it in words. Okay, last but certainly not least, okay, the scale from a playground to this drawing is 6 feet to 1 centimeter. The scale from the same playground to another drawing is 10 feet to 1 centimeter. What are the side lengths of the playground in the other scale drawing? Okay, so remember, here's what we're going to do. Okay, so don't get overwhelmed by everything that it's talking to us right now. We're going to take this and we're going to break it up into 2 parts. So this scale is 6 feet to 1 centimeter. Okay, so this scale right here is 6 feet to 1 centimeter. Okay, and I know that this side length 6 and this side length 4. So the first step that we're going to do is we are going to find the actual sides by using this scale. So this is 6 feet to 1 centimeter. So now I'm going to go up here, and I know that on this scale drawing, this side length is 6 centimeters. All right, so we have to find what the actual side would be. So 1 times 6 is 6. So 6 times 6 is 36 feet. Okay, so this actual side is 36 feet. Now let's do the width. So the same thing, 6 feet over 1 centimeter. And we know that the scale drawing is 4 centimeters. So 1 times 4 is 4. So 6 times 4 is 24 feet. So this actual distance is 24 feet. So now that I know my actual distance, I can use that to find what the new one would be if I had a new scale. All right, so here's my new scale. So my new scale is 10 feet to 1 centimeter. All right, the information that I know up here is that the actual distance is 36 feet. I'm trying to find what the new scale drawing would look like. In order to do that, I have to kind of go backwards. So remember, when I went forward like this, I multiplied. So if I go backwards, I do the inverse operation. So I'm going to divide. 36 divided by 10 is 3.6. So I multiply 1 times 3.6 to get my centimeters. Okay, so the new side length would be 3.6. So here's the next one. So 10 feet is to 1 centimeter, as, again, the actual is 24 feet over what I'm going to find out. So again, I have to divide 24 divided by 10, okay, and I get 2.4. So that's my new side length. So this is my new side length, and that is my new side length. So my answer would be A. All right, so like I said, this was just a quick review. We've done these problems for quite a while, so hopefully this just helped maybe refresh your brain just a little bit. Now what you're going to do is you're going to head back into the Zoom, and posted under classwork, you will find the Unit 1, Lesson 1 quiz that you're going to take on Kami. So you're going to do it on Kami, okay? You're going to need a piece of paper and a pencil because you are going to have to do work on here before you put it on there, okay? All right, so good luck.